Welcome to this week's Swarf and Chips. This is what's coming up on today's show, and take note because at the end of the show you will see us handing over our £1,000 cash prize draw. However, joining us today is Matt from ABB Robotics. Welcome to the show, Matt.
Thank you.
Now, Matt, I'm going to start the show a little bit differently today, right? Because I want to get into the juicy side of ABB Robotics. You've got a website here. It's brilliant. It's very corporate, but not many people will know who you are and what you do. So what is it you want to get from today's show?
Well, today I want to talk a little bit about what automation is about, how it can help the industry, and ultimately dispel some of the myths that people might have about automation.
Right, so this is a company, ABB. Let's kind of park the company for a moment. We know it's an incredible company.
Huge company, sort of infrastructure,
huge, global.
power generation. Yeah.
But ABB Robotics, you're dispelling the myths about automation. So what is it that is the fear about automation?
A lot of companies think that robotics and automation is for the big OEMs, the people like Fords and Jaguar Land Rovers, but automation is actually massively beneficial to smaller businesses. So any business that has machine tools, that has machines they are loading and unloading, what we can do is make that process a lot more efficient through automation. We can do that very, very easily and very, very cost effectively.
So if you were to walk into a company, let's actually imagine, let's visualise right now, Matt, you're walking into a company. What is it you're looking for? Because you actually do this, don't you? You survey companies.
Yes,
so what is it you're looking for to go, they could do with automation. Oh, this could check, they could do this a little bit better, more efficiently.
The key to it is though, engineers, I think, almost scared about doing it. Just pick up the phone or get in contact with you to get to get you walking through a door. It's simple.
And a lot of times we will go in and it's not right for everybody, but more often it is. And when we go into a company, we're looking for machine tools that are stood idle. Everybody is busy. The manufacturing in this country is booming. So everybody's busy, but people are sometimes too busy to be able to make those improvements. So what we try and do is go into companies, have a look for areas that we can improve. Where can we get increased volume, increased production? Where can we reduce costs? So I'm looking for machines that are stood idle when they should be producing. I'm looking for lots of different variety of parts that take time to change over. How can we make that easier? How can we make that simpler?
That's quite scary, though. If someone's saying, I'm making this part on this machine and this part on this machine, how does automation come into it? Because that, to me, is quite complicated.
Well, think of automation as the same as a machine tool. So on your machine tool, you are producing maybe several different types of components, and you're changing that tooling over. With automation, it's even simpler because some of our standard automation all works from a very simple vision system, which is designed to change over and introduce a new part in less than 5 minutes. So we can take a part, put it on a belt, teach it into the system, and the robot can then load automatically into the machine tool from that standard solution.
And does it take long to teach it into the system?
No, the initial teaching takes about 10 minutes.
Oh.
So we've got companies that have got 250 different components that they've all taught themselves. And we're talking not big corporate organisations, but smaller companies that have taken this technology on and used it to be more efficient. And in many cases, we're talking 60% increase in productivity.
So an engineer wins a great big contract. It's going to be running for 18 months, 2 years. They're thinking automation for that one component, but that's not the case. It's so simple. You can have loads of different components, so that it might pay back in return on investment 18 months. But that automation system is so easy to install and use. It can be doing loads of different components, different batches.
Yeah, payback's an interesting thing that you mentioned there, because yes, 18 months is the minimum that we try and aim for. We want to try and get better than that. We've got many companies with less than 12 months payback, and the flexibility is key. The efficiencies that people can expect to see gains with automation, the biggest one is productivity gains. Typically, an automation cell where you have a man loading and unloading a machine tool will be between 45 to 55% spindle utilisation. Now that's a typical kind of number. There are the exceptions, but that is a typical number. With automation, the more typical number is 80 to 90% spindle utilisation. So instantly you're getting more from that machine tool. The second thing that you gain is manning. So you might have a highly skilled operator, a CNC operator, running one or maybe two machine tools. With automation, we can have 5 machine tools being fed and loaded and manned by a semi-skilled operator. So this is a big gain.
Well, that's one issue that people do raise. All right, we're going to have some automation. People are going to lose their jobs.
Yeah.
That's not the case?
Not at all the case. Okay. And automation actually does the reverse. In most examples, the automation helps that company grow. It removes that repetitive task that robotics and automation are much better suited to, hence the gains in efficiency that we see. And what the guy is much better at doing, or that individual, we can move them into an operation where they can add more value. So
an engineer who's got 20 years skill,
absolutely use that 20 years skill.
Yeah.
What about floor space? Because some people might be thinking, because I know, you know, when we've previously spoken, a company will have maybe lots of parts all over the place. How is automation going to help with floor space? Because they might go, oh, I haven't got room for automation. Yeah. How do you get over that? We
have some very small systems that can fit, that squeeze into tiny little spaces. We even had one where we had to take down a corridor to get into a factory. So yeah, it doesn't need to take a lot of floor space up. And because the operators then have more time, because they're not tending the individual machines, they've got more time to do stock management, which the biggest bane of most machine shops is parts everywhere. So you've got the man talking earlier about how can we better use that man. That man can manage that stock a lot better.
And is it more of a, you know, is it a bespoke machine that you're making, or is it a standard, you know, with your automation?
Well, I was going to ask as well, engineers, you know, they're shrewd guys, they're always looking at the price and things like that, and you alluded to bespoke, you know, I want an automation system, it's going to be bespoke to my machine shop, is that right?
Yes and no. Typically, automation has been very bespoke, and that's where a lot of the cost comes from, because actual hardware costs isn't huge. The biggest part of the cost is in engineering, the installation, and the developing of that cell to that particular application. The way that ABB have approached the problem or the challenge is slightly different. We've come and developed a range of standard products that can be introduced very quickly. So we have some systems that we can install in a day. So that's
people will put
they will do. We have examples where we have installed systems in a day, and that minimises your downtime. It reduces the installation time, and because we've got 1,000 systems, we've done this over 1,000 times, so we know how to do it slick, we know how to make it efficient, and we know how to make sure that we minimise the engineering and installation costs, so that people can start getting the benefits straight away. And that's probably the key difference between a bespoke piece of automation and a standard piece of kit that we offer.
There is a big fear in the industry, but how do you explain this?
Well, one of the things that we do is we take a standard cell, and it's the beauty of having standard cells is we have these on the shelf that we can bring into a customer site, and we can take that free of charge into a customer site and give them the opportunity to actually physically try it for themselves. There's nothing better than a customer playing with a piece of kit and actually understanding it with their components in their own factory with their own people.
So you're telling me, sorry Colin, you're telling me that you are going to go out to a customer and you'll put your piece of kit into their workshop. This is any customer who, you know, you feel that needs it, or well, how do you do it?
We start off with a survey. We go in and we have a look at the potential and the feasibility and what we can do for them.
But what you're not going to do is sell it to everybody. It's not right for everybody.
No,
but
it
you
isn't
will
right for
add that value there.
But it's amazing how many people it is
Yeah.
right for, and we've already done this on a number of occasions where we've taken a cell, and I say we do it for free because we want people to actually experience it and actually see it. There's nothing better than actually people getting their hands on it and having a play themselves in their own factory.
Be aware, you might get a lot of people contacting
Bring it on,
you.
we've been more than happy to do that.
Yeah, no, that's what it's
Absolutely.
all about.
Get over the fear, get on the phone or via the website,
Yeah.
get the survey, get the robot in there, prove
Absolutely,
prove the return on investment.
Fab, are you ready for some pressure over in Technical Corner?
Bring it on.
Yeah, what are you going to talk about?
Okay, well what we want to try and do is take the 5 parts of an automation cell and hopefully explain them and how they all go together.
Fab, so good luck to you. And now it's your chance to get involved because we've got our Cycle Time Challenge.
Cycle Time Challenge.
As you'll know, we love travelling the country, visiting precision engineers and companies that are excelling in what they do, and this one's no different. I'm at Norgen Precision Engineering down in Portsmouth, or in just outside Fareham. Kevin, tell us a little bit about the company and what you do here and why you think you're so successful, because really this is a great place.
Well, generally we're just a subcontract company, but I think a lot of my success is that we have bought into the high-end market on machine tools. We've got highly skilled engineers here, so we give them the best tools that they can work with.
And you bought the business in 2002, you're 15 years in. How much has this place grown? I mean, I know you've moved a few times, but...
Well, yeah, we've moved 3 times. We're in this now in 6 years. We have grown from 5 staff to now 25. Turnover the first year was 200,000. Now we're over 2.5 million. So yeah, it's going very well.
A real success story. Now we're going to have a look at one of the parts you're making because we're now going to do our cycle time challenge from here. So let's have a look. So firstly, Kevin, what grade of material is this?
7062 aluminium.
And it comes out of one billet?
One solid piece, yes.
And what machine are you actually machining this on?
We're doing this on our Hermley C400.
So that's a 5-axis machine. Would I be right in saying this is 2 operations?
It is correct, 2 operations.
So could you just talk us through very quickly what op 1 is, which is maybe this side and then the other?
One op is the gutting out of the inside, and then op 2 we turn it over and finish the outside profile.
There is a lot of machining. There's a lot of holes here as well, drilled.
Lots of angular holes, yes, and the finish on the outside is more important than the inside, so a lot of care is taken on the outside.
So it looks like a fantastic part. That's the cycle time challenge for this week. How long is this part taking to make from start to finish? It's 2 ops out of 1 billet of aluminium here from Norgen Precision Engineering.
Technical Corner.
Welcome to Technical Corner. Matt, thanks for joining us today. First thing, I want you to just go over the 5 elements of putting a robot cell into a machine shop.
Well, the 5 elements of a robotic machine tending cell are, well, number 1 is the robot itself. Then we have the grippers, the bit on the end of the robot that picks the part up. That could be a single gripper, which would be unloading and then loading the part in, or a double gripper, which would be unloading and loading the part at the same time to minimise the time that the machine is stood still and not cutting. The third part is how do we get the parts from a bulk stillage, a conveyor or a pallet to the end of the robot. The fourth element is the interface to the machine tools. How do we interface that? How do we get the system to talk to each other? And lastly, there are quite often ancillary operations such as deburring, washing or measuring that can go on, and that's the 5th part.
Right, if I was buying a robot, my first question would be, how easy would it be to interface that robot with my machine?
It's a very good question and something that gets asked quite a lot. Because we've got standard systems, these are standard systems, there's over 1,000 of them in operation. We have pretty much most interfaces already written for most of the machine tools that are out there. And we can easily link to it, even for the safety as well. We can communicate via ProfiSafe directly to the machine tool, so that we don't have to hardwire anything into the machine.
So to a certain degree, it's becoming modular.
Yes.
Now this leads me on to my second question. I've got the robot on my shop floor now. It's interfaced with the machine. How easy is it to program the robot? Because is it a misconception of it that it's complex?
Yeah, absolutely. It's very, very straightforward to program. There are certain elements that we have to understand. We have to understand where the component is. Because of the way our standard systems work, there's no complex tooling, so it keeps it very, very simple. The vision system in the flex loader systems is designed specifically for part orientation and gripping, which makes it very, very simple to program. Within about 5 to 10 minutes, an operator with a reasonable level of understanding will be able to program that system for a new component and a new part.
Right, so anyone could learn to program this?
Absolutely, yes.
In a short period of time?
Yes.
Now, moving on to the components, the programming is simple, but what if I had complex components or castings, for example? How easy would it be to pick up them components?
And that's, again, the beauty of the vision system. It doesn't matter whether it's a billet, whether it's a complex shape like a casting, we can recognise the part very, very easily and direct the robot to it without any major robot programming. There's no robot programming needs to be done for the robot to recognise and be able to pick that part up. And that's the key thing that makes this system very, very simple and easy to reprogram. We have customers with 250 different components that they run through the same system.
But would you have to change the grippers, different grippers?
Yes, you do. You can have grippers that cover a range of components, so it's not necessarily you would need one gripper for each different part. You can have one gripper for a range of components, but we can have quick change jaws, so you can change over the gripper very, very quickly, which you would have to change over the tooling in the machine anyway.
Right, now a really important part to the process is getting the components from the stillage or the conveyor to the robot. Now, there are different ways of doing this. What is the most cost-effective way?
Yes, you're absolutely right. There's many different ways, and that's where our range of standard cells comes into its own. We've got systems where you can literally simply load parts onto a conveyor belt, and that goes into the cell, and they come out of the cell. This enables one operator to tend up to 5 machine cells. So it's the most cost-effective and probably one of the most efficient ways of running a machine cell. Some people don't want to do that. Some people want a whole stillage that they want to drive up to a machine. We've got a system that'll tip the whole stillage up. It'll slowly decant out all of the parts in there, so great for components up to about 3 or 4 kilos. That will then cycle around and separate out the components ready for the robot to pick up using the vision system.
So if you were doing components that are heavier than 3 or 4 kilos, what options would be available?
So heavier components, so larger components often come on a pallet. That pallet may have multiple layers stacked up, and for that we have a 3D pallet picker system where, as long as the parts are semi-orientated, so that means they are in roughly the same kind of direction, they're not completely random, they might be slightly different angles in the pallet and slightly different heights. We can recognise the location, the height, and work our way down the pallet. And all of that uses the same easy to program vision system, so there's no added complexity for that 3D pallet
So this vision system is effectively just simplifying the old process, this new technology?
Yes, absolutely, and tying in all of the other elements of the cell, so the conveyors, the robot, the interface to the machine. That system ties all of those things together and makes it really nice and simple, so you've only got one thing and one screen to look at.
That sounds fantastic. Now, once the old process is up and running and you've got one machine up and running, are there any other add-ons? For example, deburring?
Absolutely, and more often than not, a customer doesn't just want to have load and unload of a machine. I'll always advise, let's start with that, because that's generally where the most gains in efficiency will come from. And once that's up and running and that process is stable, then we can introduce standard bolt-ons. We've got standard debur stations, standard wash cells, standard blow-off stations and standard part marking stations, as well as a host of other add-ons and bolt-ons that we can introduce into the cell at a later stage or with the main automation.
Matt, thank you very much. It's
Thank
certainly
you.
been educational for me. I hope it has for you. Back to Lindsay.
Well done, Matt. That's incredible. We always have to congratulate everyone because we do put a lot of pressure on you on Technical Corner.
Like to keep you on your toes.
Yeah.
Absolutely.
But, Matt, we've had ABB, huge global company, loads and loads of different solutions. You'll hear about robotics, machine tending. So you've got an engineer, he's loading his parts at the moment, manually, everything like that. Can you give me a quick summary how to alleviate the fears and also the process, get in contact, what happens about automation with you guys?
Yeah, thank you, Colin. The main thing we want to try and do is make people more productive, increased productivity, and we want to try and do that easily, make it more accessible. So our products are flexible, easy to implement. In some cases, I think that we've seen a little video where we can, we've got a system going in less than a day, a little time-lapse video of a system going in less than a day. The process, get in touch with us. We'll come in, we'll have a little look around, we'll discuss, most importantly, the return on investment. There's no point in doing it if it's not going to give you a return on investment. That's the first thing we look at. Does it give you a return on investment? Once we have a look at that, we look at the feasibilities and try and give people a comfort feeling that these systems are easy to use. And we can do that by bringing a system in. We can put it down on the shop floor free of charge for people to have a play with, for people to get their heads around and understand what how the system would work with their own parts.
Two quick figures and statistics, sort of numbers we've bandied around earlier. Productivity, sort of from what percentage up to what percentage?
Typically, a standard manually loaded cell will be between 45 to 55% spindle utilisation. Automated, that will go up to 80 to 90%. So that's the first big gain.
Doubling it. What about, and then engineers always look at that when they're buying a new machine tool, return on investment.
Return on investment very much depends on the application, but we like to do less than 18 months payback. There are many systems that are less than 12 months payback.
That's amazing.
It is really impressive figures. Following on from that, is something that we've been talking about for quite a while, is Mac.
Yes.
Are you there?
We certainly are. Stand H19400. I remember that.
You got it,
well
you got it
done,
right. Yeah,
I'm
no pressure.
impressed. Yeah. And what have you got on the stand?
We've got a range of some of the flex loader systems we've just spoken about in the show today, and we've also got, which is quite exciting, a chocolate machining robot. So a robot.
Oh, hold on, lucky Joe wasn't here. Chocolate machining.
Oh, you guys, every single time when there's food that is mentioned, everyone's like, Joe,
So
where's Joe?
can I suggest you don't tell Joe what your stand number is?
He knows now, he's watched. Well, as excited as we are about Mac, we're just as excited to watch Paul hand over £1,000 to our prize winner.
Paul's handing over cash.
Yeah.
Oh, we need to see that.
Yes, thank you guys. I hope you're having a good time back in the studio this week talking about automation with ABB. Now, yeah, I'm all over the country this week. I've been down to Portsmouth and I'm now up to Wigan, where I'm come to present Paul Briley with his £1,000 cash prize from Dukewell Precision. Paul was the lucky winner of our prize draw just before Christmas. So, Paul, here you go. Here's your £1,000 cash. What do you say to that?
That's absolutely brilliant. You know, we never win anything us lot up north, but you know, that's brilliant. That. Thanks.
And what are you going to do with it?
It'll be spent on something on the shop floor, unless the wife finds out about it, and then.
Oh, that's good. So this money's actually going to go back into the industry.
Oh yeah, it will be. Yeah, definitely.
Really good to hear. Really, I'm really pleased that you won this, Paul. Remember, we do regularly do prize draws on Swarf and Chips, so you need to keep watching the channel to see what's happening. Tell us a little bit before we go about Dukewell Precision, what you do here, what sort of parts you make.
We do mainly subcontract machining, anything from, as you can see, Inconel, aluminium, stainless. We cover a vast, array of materials.
And it's quite an interesting story because you've not been going that long, have you?
No, we started off in February with one machine, and then we got another one in May, and we've got 4 machines now, and we've got another 2 machines coming by the end of the month.
Now, I'm assuming before you started the company, you've been in engineering all your life, have you?
Yes, since I was 16, so it's...
So from going to being employed to being an employer, for example, what's different?
The hours. It's hard work, but at the end of the day, you're doing it for yourself, you're doing it for your family, so the wife gives me a bit of grief every now and again, but you know, the hours have got to be put into, you know, benefit the company really.
And Paul, to summarise, if you had a message for our audience, which is huge, to tell them about what Dukewell Precision do and can offer, what would you say?
Well, we offer everything we do is precision parts. You know, we work to very tight tolerances. Our delivery is always bang on. You know, we're up to 98% up till December, you know, which is quite good.
Well, I've got to say, I'm really pleased for you that you won this cash prize, and even better that it's actually going to go back into the industry. Keep watching MTDCNC and Swarf and Chips, because we will be doing more giveaways like this in the coming year. But in the meantime, back to you guys in the studio.
Well, who wouldn't want £1,000? That's an amazing prize, isn't it?
More interesting seeing Paul hand over £1,000 in cash.
There
Never
is
happens.
that.
I've got that in film.
Well, thank you so much for joining us, Matt. We'll put all your details on the screen for anyone who wants to contact ABB. However, as we always do, we hand over a Swarf and Chips goodie bag. I have a request for you, though. Will you wear something from that?
Absolutely will do. Look forward to it.
And put it on social media for us as well. Thanks for watching this week's Swarf and Chips. Make sure you like, comment and subscribe, and don't forget to put your cycle time challenge in the box below. If you want to watch any previous episodes, click on the links here. And as we always say, keep those spindles turning.